Hey guys, today we are doing similar figures. So 8.1, we start with scale factors. We can label scale factor is K. Is the multiplier used on each dimension to change one figure into smaller or bigger figure. Okay, so we call enlargement if we have a smaller figure to a bigger one. So your answer K will be greater than 1. Reduction will be bigger to a smaller figure, so your K will be smaller than 1. Sometimes they can be equal, so K equal 1. Then we have similarity ratio. It's the ratio of the length of two corresponding sides in pair of similar figures. All right, let's figure it out. What is the scale factor of ABC quadrilateral, ABCD to quadrilateral, EFGH? Okay, so we can see the figure is smaller, right? It's getting smaller. Okay, so able to find a scale, we will do so I call ABCD is the old or the original figures, and I'm gonna call this one is the new figures. So to find K, we take the new and divide it by the old. So we have 8 divided by 12. Okay, and we simplify them. They're both divisible by 4, so then I will have 2/3. Okay, so yes, is this less than 1? 2/3 is less than 1, and then that's right? So your K is smaller than 1. The figure is smaller. All right, next one. We have correspond part of similar polygon. In diagram, triangle ABC, I don't know why this one cut off, is similar to triangle DEF. You can write triangle ABC is similar to triangle DEF. Like this wicket right here is similar. A similarity transformation preserve angle measures, so corresponding angle are congruent. Okay, so angle, you can see angle A congruent with angle D. Angle B will congruent with E. They also do 2 mark like that. A similarity transformation also enlarge or reduce side length by a factor of K. Okay, so corresponding side length are proportional. All right, corresponding angle are congruent. Ratio of corresponding side length. Again, we also, so we have ABCD, similarity transformation to DEF. So this is the old figure, the original figures. This is the new one. So we're gonna have the ratio of the new one over the old one. Okay, and it's also similar to what we do for K. Okay, so scale factor and corresponding part of similar polygon is the same thing, the same ratio. Next one, if 2 polygons are similar, then the ratio of 2 corresponding length in the polygon is equal to the scale factor. We just said that. Next one, okay, we talk about parameter in similar polygon. If 2 polygons are similar, the ratio of their parameter is equal to the ratio of their corresponding side length. Okay, so we, instead of adding all the side and put it over to all the side of the second figure, we also can just pick one pair of the ratio and put it over the other one. So for example, instead of doing PQQRRSSP over the entire parameter KLLMMN and AK, we only need to do one pair. That would be the answer. So PQ over KL. Again, new to old ratio. All right, for area, similar, but because this is area, so we're gonna square the ratio. Okay, so again, we have polygon KLMN similar to PQRS. So we just need to pick one pair. So let's say we pick PQ and KL. whatever you have, you square them. That will be your solution. Here's some example. In exercise 1 and 2, polygons are similar. Find the value of x. Okay. We're gonna set up proportion. That's your goal, is to find the missing side length. Okay. And doesn't matter what you put in for the first ratio. The second one have to be corresponding. For example, the first figure I can do 3/7. But the second figure, the 3 are also corresponding with the 2. So I have to start with 2 instead of x. Okay, so if I have 3 to 7, I have to do 2 to x. And then I can cross multiply and so for x. So I have 3 times x, 3x, 2 times 7 is 14. X is 14/3. And then you can give me a fraction for your solution. I have 4.7. All right, next one, I have 2 triangles. They are similar because the angles are congruent. Okay, so let's say I want to prove for x, and I put it, the ratio go with the 8. Okay, so the next ratio, I need to find something corresponding with the x. And I can see the x is from the side with 1 mark to the 3 mark. So I'm gonna have to find the one that's similar to that. 1 mark to the 3 mark. So x will go with 25. And then if I pick 8 is 1 mark to 2 mark, I have to do the same thing. 1 mark to 2 mark, 20. And I do cross multiplication. I have 20x equal with 8 times 25 is 200. X is 10. So you can pick the 12, but if you pick the 12 side, it have to go with the 30 if you choose to do that. All right, next one we have polygon ABCDE congruent with KLMNP. Find the scale factor of ABCDE to KLMNP. So we have a transform from ABCD to KLMNP. So we can pick 2 sides. I pick this side, I'll pick this side. Okay? So remember the scale factor is we want to see how big they are, how bigger they are, and how smaller they are. So we can see they are bigger, right? For sure. So their K we expect from ABCD to KLMN, it have to be, K have to be greater than 1. Okay? All right. So we're gonna do new to old again. We can do KL and AB. KL is 3 and AB is 2. So the scale is 3/2. Find the scale factor of the opposite one. We flip this one. So if we do that, we also can flip the fraction that we just have, right? All right, find a value for x, y, and z. All right, where's x? X down here. So if this is 1, since they are similar, this also need to be, oh, they are similar. So how many times they have been different? 3/2 times, right? So if this is 1, this x for LM will be 1 times 3/2. Which is 1.5, 3/2. Okay, you can do 3/2, we don't mind. Okay, so all the x will be that. The y is 3√2 to y. I'm gonna have to take 3√2 times 3/2. Okay, this 1.5 bigger, right? Okay, 3 root 2 times 3 over 2 is 9 root 2 over 2, which is about 6.4. Okay, all right. I need space to find z. Okay, z is, the angle. Okay, so for similarity angle, they will be congruent. So if angle K was 45, it's gonna be the same at angle A for 45 degree. Find the parameter of each polygon. Okay, so parameter means you're gonna add all the sides together. So let's do parameter of A, B, C, D, E. You add all the sides. So we have 2, add 1, add 1, add 2, add 3 root 2. I get 6 plus 3 root 2, which is about 10.2. Okay. You have option that you can add all the side of K, L, M, and P, or we can multiply 10.2 by 3.3 over 2 by the K. Okay, and if I do that, my new K, L, M, and P will be 10.2 times 3 over 2. I have 15.4 about that. Okay, the exact answer will be the one that have the square root, but I can round them a little bit. Find the ratio of parameter of A, B, C, D, E to K, L, M, and P. Okay, parameter, you can take two sides and put it like a ratio. So I will do A, B, and K, L, right? And again, we're gonna do new to old. This is the old one, original one. This is the new one. So we're gonna do new to old. And we're gonna need to have one side. So we're gonna do 3 over 2. We pick KL and AB. Okay. Or we can also do parameter that we just found, which is 15.4 over 10.2. You get the same thing. All right, for area, we take the parameter, or we take the side, and then we square them. We also do new to old. So 3 over 2, you square them. You have 9 over 4. Okay, the length of the side of a triangle in ratio 3, 5, and 7. Parameter is 120. Find the length of the shortest side of a triangle. All right. So parameter means all sides add up, right? So we doesn't know the side, so we call the side is x. And then we're gonna have 3x plus 5x plus 7x is 120. So we have 15, no, am I right? Yes, 15x is 120. X is 8. So the ratio, the smallest ratio is 3. So if x is 3, the shortest side will be 24, right? With the 3. Shortest side is 3x. 3 times 8, 24.